Welcome back to Science Maximizers. Welcome back to our channel. Today we are going to see a problem on current electricity. That's June 2018. The question reads: Figure 1 shows an electric circuit with two power sources connected to the resistors, as seen in this diagram. A. Determine the current through R, so through the resistor R. B. The value of R, and C, the EMF E. Now this is the typical diagram, and so what we observe is, in order for us to calculate that, we have two power sources, that's the 15 volts and the E that we don't know, and so we have to calculate the value of the current I. So let's begin with the first one. We are going to distribute current. Let's say the 15 volt is our main source, and so this 15 volts sent out current in this manner. Here we have the 3 amperes, and here we have the 1 ampere. And so this means that the current entering or passing through the arrow ohms resistor, let's call it to be I. And so what we get from here is the sum total of this current and the current I, or the 1 ampere and the current I, should give us the 3 amperes, since we are assuming that is from our source, 15 ohm source. We can still use your own orientations in order to get the values of this current. So the first orientation is, we have the 3 ampere. It will be equal to the sum total of I plus 1 will give us 3. That's from Kirchoff's current law, and so we know that I is simply equal to 2 amperes. Now another possibility is, you can release your arbitrary current here, I. Let's say I1. When it reaches the junction, it splits into two components, that's I2 and I3. So here you are going to experience a backflow, because it is flowing against the conventional flow of current on that source of EMF. And so it means that the value of the current here will definitely be negative. And so it means I1 from Kirchoff's current law, I1 will be equal to I2 plus I3. But the value of I3 was given, and since the direction of our current opposes this, then it's going to be negative. So, and our I2 follows the convention of the current given on the circuit. So our I2 is 3 plus I1, which is negative 1, which still gives 2 amperes. So you can decide to take your own orientation and apply Kirchoff's current law. Now the value of R, we are going to consider two loops. I'm going to call this loop 1 and I'm going to call this loop 2. And so in order for me to get the value of R, we are going to apply Kirchoff's voltage law on loop 2. Now in order to apply this, let's get the respective direction of our voltage. So the source of EMF is going to have the voltage direction of source, that's the direction of potential. And so since the current flows downwards in the 3 ohm resistor, then the voltage across the 3 ohm resistor will definitely be upwards. Permit me write 3 ohms with you. So we are going to have this direction as V3 ohms. And as current flows, I passes through R and goes upwards. So it means we are going to have our voltage drop downwards. That's VR. And so applying Kirchoff's voltage law, that's B. Kirchoff's voltage law in loop B, we have the positive convention is the anti-clockwise, as the arrow indicates. And so if we begin from the source of EMF, we have 15 volts, which is in the convention, minus V3 minus VR is equal to 0. So this means, but we know that the voltage drop across the 3 ohm resistor is equivalent to the current passing through that, flowing through the resistor times the resistance. So it's going to be 15 minus 3 ohms times 3 amperes minus VR. Now the current going through the arrow ohm resistor is simply this current I, which has a magnitude of 2 amperes. So it's going to be 2 times the resistance R equal to 0. And so we now get the value of R. So making R the subject, we have 2R. We're going to have 9. 2R will be equal to 15 minus 9, which is 6. So this means 2R is equal to 6, and so we divide by 2, from where we get R to be equal to 3 ohms. Now the value of the EMF, C, the value of the EMF, let's do it somewhere here. Let's apply Kirchoff's voltage law on the 1. And so here, this is positive convention for the direction of potential in the source of EMF. And so as current, the 1 amp flows through the 6 ohm resistor, we are going to experience a voltage drop in this manner. So I'll call this V6. Likewise, the V3 remains unchanged. And so following the orientation of our loop, so it shows that anti-clockwise is positive. So the V6 is in the positive convention. V6 is in the positive convention. So we have V6. We have V6. So we have V6. Let's use another color. V6. Then as it goes up, it is in a positive orientation in V3. So there will be plus V3, then minus E is equal to 0. So this means E is simply the negative into V6 plus, sorry, E will be equal to V6 plus V3. But what is V6? V6 is the voltage drop across the 6 ohm resistor, which is the current 1 times the resistance. So it is 6 times 1 plus V3. V3 will be 3 times 3. That will be 3 times 3. So what we get here is 3 times 3 is 9 plus 6, which gives 15 volts. So it means the value of this EMF is 15 volts. And here is 3 ohms. And the current flowing through is 2 amperes. So this brings us to the end of the video. Thank you very much for watching, and see you in the next video.